Hello students, we have seen what saturated and unsaturated hydrocarbons are. Let us now learn about the classification of saturated and unsaturated hydrocarbon compounds. As we know, hydrocarbons are classified into three groups or three families: alkanes, alkenes, and alkynes based on the bonds they form. The alkane group consists of saturated compounds. Thus, all alkane compounds have only a single covalent bond between all their carbon atoms. The simplest hydrocarbon of alkane group is methane. Can you recall methane structure? Yes, it contains a single carbon bonded to four other hydrogen atoms by single covalent bonds. Its molecular formula is CH4. What about the maximum number of carbon atoms forming chains in alkanes? Well, it's not possible for us to count the maximum number of carbon atoms that make one chain. This is because the carbon chains of these compounds tend to be very long, as they have high number of carbon atoms. So how do we know about such higher alkanes? I mean alkanes that have very large carbon atoms. For this, we have a general formula to study. Yes, a general formula. This formula gives the number of carbon and hydrogen present in hydrocarbon of alkane group. And that is CnH2n plus 2, where N represents the number of carbon. So, can we represent all the alkane compounds with this formula? The answer is yes. And that is why it is called the general formula of alkanes. In addition, as you know, the name of each hydrocarbon compound is formed from the root word, which depends on number of carbons present in the hydrocarbon. For example, if a hydrocarbon contains one carbon, its name will have root meth. Similarly, if it has two carbon atoms, the root will be eth. And what if compound has three carbons? Yes, it will have root prop. Now I tell you the root of the word is hex. How many carbon atoms does it have? Correct, it has 6 carbons. And the name of each hydrocarbon in the alkane group has a common suffix ane, derived from an alkane word to symbolize a single covalent bond. So now, can we study and name any alkane compound with all these information? Yes, definitely. Let's do then. Say if we have n equal to 1. So we have only one carbon atom in the compound. So what will be its root word? Yes, it would be meth. Hence the name of the alkane compound would be meth-N, that is methane. Now as per formula CnH2n plus 2, what would be the number of H atoms, that is hydrogen atoms? If we substitute N equal to 1, in our formula we get H as twice the number of N plus 2, that is 2 into 1 plus 2 equal to 4. So we have here one carbon bonded to 4 hydrogen atoms by single covalent bond, that is CH4. It is because we are studying alkane compounds, they have only single covalent bonds. Thus 4 bonds will satisfy the 4 valencies of carbon and individual valencies of hydrogen as well. Now pause the video and think, did we get the correct compound by this formula? Yes, we did. So in general formula CnH2n plus 2 of alkane, now let us take N equal to 2. So the compound will have 2 carbon atoms bonded by a single covalent bond. And the root word for this compound would be eth and suffix ane, as it belongs to alkane family, which makes the compound name ethane, that is ethane. Thus, the alkane compound containing 2 carbon atoms is ethane, isn't it? Yes. What would be the number of hydrogen atoms then? Simple. Put N is equal to 2 in the formula and calculate. We get H as 6. Thus, its chemical formula would be C2H6 and its structure can be represented in this way. Now here, one valency of carbon is satisfied by forming one single covalent bond with the other carbon atom and remaining by bonding with hydrogen. Let us now proceed and take N equal to 3 in the general formula of alkane. And can you guess the name of this compound? Yes, it is propane. Since there are 3 carbon atoms here, the name will have root prop and the suffix ane since we are talking about alkanes, which makes propane an alkane compound containing 3 carbon atoms singly bonded with each other. If we calculate its molecular formula, we need to put N equal to 3 in the general formula. And we get number of hydrogen atoms equal to 2 times N plus 2, that is 2 times of 3 plus 2, which is 6 plus 2, 8. This is because N is 3 here since we are talking about propane. That means there will be 3 carbon atoms here. The structure of propane can be represented like this. Again, observe here too that all carbon atoms are bonded by single covalent bond with each other and also with hydrogen atoms. This means one valency of each carbon is satisfied by making this bond with other carbon atom and all other remaining valencies are satisfied by bonding with hydrogen. And students, this is how other carbon compounds of alkane group can be represented using the general formula CnH2n plus 2. This also means that as we increase the number of carbon N, we will get longer and longer chains of carbon atoms, which are always saturated, and thus called as saturated chains of hydrocarbon compounds. In the coming videos, we will learn about alkenes and alkyne compounds.